USA just revealed fully functioning female robots. With robotics becoming more popular and artificial intelligence gaining traction among researchers, scientists, and mathematicians, it wasn't long before the two were combined to create an AI robot. In short, when we think of AI-powered robots, we think of something far off in the future, not something that can be used today. However, we rarely look into the achievements of artificial intelligence, what is happening in robotics, and what types of robots have already been developed. Researchers are attempting to make it not only more advanced and capable, but also more human-like. Researchers are attempting to give robots the ability to sense and detect temperature changes, as well as infuse emotional quotients and other capabilities. They're also working on robotic skin, which will help machines understand touch, temperature change, and other senses. So in our today's video, we're going to discuss some AI humanoid robots developed by USA. Hello everyone, welcome back to our channel, a platform where you can get all the latest updates and news about a large spectrum of science, technology, entertainment, and whatnot. So hurry up and subscribe to the channel to get the regular dose of awesomeness from us. Without any further ado, let's start. The first one is Atlas. Atlas is a bipedal humanoid robot developed primarily by Boston Dynamics, with funding and oversight from the Defense Advanced Research Projects Agency in the United States. Originally, the robot was intended for a variety of search and rescue missions. It is claimed by some companies to be the most agile humanoid ever created. Its body shape is so dynamic that it can move quickly and balance itself on a variety of terrains by using all of its body skills. The robot can do a variety of things, but some of its favorites are running, jumping, and backflips. Its advanced AI systems enable it to detect obstacles and navigate through a variety of terrains. The physical structure is worth mentioning. Atlas's height is 150 centimeters and weighs 80 kilograms. The average speed of its motion is 5.4 kilometers per hour. Atlas's development has been nothing short of remarkable. Apart from the flashy moves, it demonstrates some very intriguing fundamental abilities, such as adjusting its balance when landing awkwardly. According to Boston Dynamics, the engineers were able to generalize Atlas's behavior by giving it a set of template behaviors, such as jumping and vaulting, and allowing it to adapt those behaviors to new scenarios. However, the robot still has trouble with some very basic skills. When Atlas misses a jump or loses its balance, for example, it can fall flat on its face. Primates instinctively stretch out their arms in such situations to cushion the impact of the fall and protect their head, neck, eyes, and other vital organs. These abilities are developed long before we begin running on narrow ledges or jumping off platforms. A complex environment, such as a parkour track, aids in the discovery and resolution of these issues much more quickly than a flat and simple environment. Moving forward on to number 2, we have Robotic Aquanaut. Robots are being used in more extreme environments such as the ocean, where they can be found tracking marine wildlife and water pollution, hunting invasive species, and even mapping threats to coral reefs. Of course, this makes sense because aquatic environments, particularly those in the deep sea, are notoriously difficult for humans to navigate and often necessitate a high level of expertise and specialized equipment. The Aquanaut, a shape-shifting subsea robot, is one possible solution. The Houston Mechatronics developed Aquanaut can quickly transform from a submarine to a mermaid, transforming into a semi-humanoid aquatic robot. The company is revolutionizing the underwater robot industry with this device, creating a machine capable of performing operations and repairs in deep waters that are too difficult for simple robots, but dangerous for humans. Aquanaut was created specifically for the upkeep of underwater oil and gas plants. The robot will travel in submarine mode to its destination in deep waters, where it will transform into its humanoid form and unleash its powerful weapons. Each arm does, in fact, have sensors and axes of movement, just like a human arm. Aquanaut isn't quite ready to plunge into the abyss yet. This is why technicians are putting it through its paces at NASA's Neutral Buoyancy Laboratory, a massive pool with 23.5 million liters of water and a maximum depth of 12 meters that is used to train astronauts in weightlessness. Next, we have Stuntronic. You've probably seen Stuntronic technology in action if you visited Avengers Campus at the Disney California Adventure theme park. More specifically, the human actor who first steps out onto the roof of the Web Slingers attraction's building before sneaking off for the Acrobat robot to make its grand entrance, capable of somersaults and even backflips. Stuntronic technology was created by Walt Disney Imagineers to create superhuman flight through the thoughtful and innovative application of technology. It accomplishes this by fusing advanced robotics with the study of untethered dynamic movement. The robot created by Disney Imagineering is capable of performing difficult tricks such as somersaulting, being shaken on a rope, changing a landing trajectory in flight, and striking a superhero pose. Furthermore, the robot's legs can be bent to knees and its hands can only turn in a shoulder. Sensors enable the humanoid to track the provision and stop rotation in time for landing. Accelerometers, laser gyroscopes, and a built-in computer with corresponding software provide such capabilities to the robot. Sensors enable the humanoid acrobat to track the provision and stop rotation in time for landing. Moving forward to our next one, we have Cassie. Cassie the robot, created at Oregon State University and manufactured by OSU spin-out company Agility Robotics, has set a new record by traversing 5 kilometers in under 53 minutes. Cassie was created with a 16-month, $1 million grant from the Defense Advanced Research Projects Agency, or DARPA, under the direction of robotics professor Jonathan Hurst. Cassie has been exploring machine learning options for the robot since her introduction in 2017. In collaboration with artificial intelligence professor Alan Fern and OSU students funded by the National Science Foundation and the DARPA Machine Common Sense program. Cassie, the first bipedal robot to use machine learning to control a running gait on outdoor terrain, ran the 5K untethered on a single battery charge on Oregon State's campus. Hurst, who co-founded Agility in 2017, said, "The dynamic robotics laboratory students in the OSU College of Engineering combined expertise from biomechanics and existing robot control approaches with new machine learning tools. A holistic approach like this will allow for animal-like levels of performance. It's a thrilling prospect." Cassie, who has knees that bend like an ostrich's, learned to run using a deep reinforcement learning algorithm. Cassie has learned to make infinite subtle adjustments to stay upright while moving, which required dynamic balancing, the ability to maintain balance while switching positions or otherwise being in motion. Hurst believes that, like the automobile, walking robots will become commonplace in the future. The science and understanding of legged locomotion have been a stumbling block, but research at Oregon State University has led to several breakthroughs. So, what do you think about these humanoid robots? Which of these do you find the most impressive? Tell us in the comment section. With that being stated, that wraps up our video for today. If you enjoyed this video, give it a thumbs up, also subscribe to our channel to get more amazing videos like this, and push the bell icon to get the updates faster. See you soon in our next video. Until then, peace.